All right, so we are starting, yesterday we started the brand new chapter. So for those of you who weren't here, everything's posted on Teams. We did do the notes on the front page and then skipped to page 33. But this was your homework right here. Let's go through it. Some of you are going to be off maybe by 1 degree. I'm going to be honest with you. You have to be as accurate as possible with these. Which takes a little bit of thinking, a little bit of manipulating the reference table, maybe a straight edge. Let's hear what you had to say. Let's go around the room. Jeff, why don't we start with this oh, you can't see the board, can you? What's the very first Fahrenheit that you got there?
I think I got 158.
I also got 158. So hopefully that shows up. Yep, 158 goes right there. Destiny, what'd you get for the Kelvin for that one? 343. Cassie, how about you for Fahrenheit for the next one down? Okay, I got 8. You got 8? All right, and so being off by 10 is not, or being off by 2 is not a huge deal, but let's just see what we get here. So 260. Here's 260. I do recommend using a straight edge. Oh, maybe having your paper straight too. 260 does get us 1 line below the 10 mark. So that is clearly 1 line below. So that is, remember, they go up by 2s on that side. So that is 8. Kat, do you have your homework done? No, none of it? Okay. How about Keith? Do you have the Celsius for this one? -13. Did you guys all have -13 who did it?
No.
No, what'd you put? 27. I think that's wrong. Right? Oh, no, you didn't do something wrong. But it is wrong, but you did what I thought people might do. So what I'm saying is, was it 260? Was that the number? Yep, here's 260. What you did, I think you probably did this, which is what I had explained to do. And you counted -20, -21, 22, 23, 24, 25, -26, -27. But take a look. We're really between -10 and -20. Remember, when you're counting in negatives, they get bigger as you go down. You were counting like it was a regular number and going up. So when you're here, so this time it might have helped to use your scrap paper out underneath. So there is -10, -11, -12, -13. That's super important that you pay attention to those negative numbers, because counting does get weird when we're in the negatives. So anytime you have a negative, take the time to double check. No, I think it's very common. Everybody's gonna make that.
Even if I make it on the 27th, so that's why I didn't even notice it.
Okay, yeah, then you probably didn't even notice the negative. So yeah, definitely -13 for that one. And I'll say it again, even though it's not what Jeff did wrong, double check. Anytime you're in the negatives, make sure you're double checking your answers. Felicia, your homework's done? Thank you. All right. I guess for the sake of time, I'm gonna go a little faster and you guys can tell me if you agree. How about that? So for this 40 Celsius, I had 104 Fahrenheit. Anybody get something different? All right, and then I had 313 over here for Kelvin.
Yeah, I got that.
You got that? Perfect. All right, for the 60 Fahrenheit, I'm actually going to show this one. 60 Fahrenheit, make sure you don't make that mistake. I think it was clear to see with the 60 Fahrenheit that it didn't line up perfectly with the 15. So there's the 15 line right there.
I got you.
So you got 16. Okay, good. And then on this side, but then again, I don't know if it lined up with the 16 perfectly either. It's a little above, but I would have gone with 16 for that. So 16 for this one. And then 60 Fahrenheit. Sorry, give me 1 second. Okay, there's 280. There's 285, 86, 87, 88, 89, 289. Good. All right, we're on the same page then. All right, how about this one? I got 62 Fahrenheit. And I put 16.5. Now I'm confused what you put 17? All right, so 290 right here. Right, 290 Kelvin, is that what we're doing? Yep. So 62 definitely, there's 15, 16, 17. So yeah, 17 Celsius. Any questions yet?
17, what are we, 64?
2 lines above 290, 290, 290. It's only 1 line above for me. If I line it up perfectly with the 290. I'm not sure if my paper's straight. 290 was only 1 line above for me. And then finally, what do you guys give for that next one? Not finally, I don't know why I said finally. How about this? Negative 40 Celsius, what is it in Fahrenheit? Isn't that weird? Negative 40 for Celsius and Fahrenheit. Did you question that at all? Seems weird to me. No, you shouldn't question it. It's clearly what it says. Clearly negative 40s line up perfectly. It's weird, but it does, even if you do the math. And then I got 233 on that side. Here's where I question your abilities to count in negatives. What'd you get for the next one?
I probably got like negative 34.
Let's double check this one. 240, way down here. Move it up. 240. I can't do this sitting down. 240 right there. First of all, is it 20 something, negative 20 something for Fahrenheit, or negative 30 something for Fahrenheit? We are, what I'm saying is we are in between the 20 and the 30. So we're negative 20 something. And when I count negative 20, 22, 24, 26, 28 this time, darn it. How did I get to be the wrong one? Hate when that happens. You're right, I got negative 28, but that's not what you said either, is it? It was negative 28. Do you see why you did the same thing again though, Jeff? You said it was negative 34.
Oh.
So you.
You're talking about Celsius?
Oh, were you talking about Celsius? Because I got negative 33. Were you talking about Celsius or Fahrenheit?
Celsius.
What'd you have for Fahrenheit?
54, negative 54. I was way off on that.
Yeah, you definitely were way off on that one.
Maybe I counted it wrong.
Okay, we're gonna have to double check some of those. The 28, and I had negative 33. Did you guys have that as well?
Yeah.
Okay. And now let's wrap this up. 20, not 20. Yeah, 24. And 297. And then 122. And 323.
Yeah, I got that.
You got those? We comfortable enough with those? A little bit of work still needed. We'll throw some more practice out there over the next couple of days. We need to pick up where we left off on page 33. If I recall, we did the definition of relative humidity, right? Talked about how it's measured in percent. So but we didn't fill in these blanks, right? Let's work through this. So what relative humidity is very similar to how I figure out your grade. Your grades, if you remember, are how many you got right, out of how many you could have got right, times 100. So let's talk about if the air gets 100. What does that mean if the air is 100% humidity? No, nothing. What happens if you get 100 on your test? What does it truly mean to get a 100 on the test?
You got 0 wrong.
Okay, you got them all correct. Everything you could have got correct was correct. So what happens if the air has 100% humidity?
They got no answers wrong.
What'd you say, Zach? What'd you say? Okay, so it's not 100% of the air, but
Oh.
100% of the space available is filled with water. So when the air is 100% humidity, it means it's holding as much as it can. So it's all filled up. What's gonna happen then? If the air is 100% filled up with water, what's gonna happen? Can it hold any more?
Yeah.
No, so if it tries to hold more, if you have a sponge that's 100% filled up, what happens if you try to add more water to that sponge?
It'll just like explode.
Well, okay, I don't think sponges are gonna explode, but I'd like the answer, it leaks. So what about if the air is 100% filled up then and we try to add some more? It's raining. So 100% humidity is when it rains. Let's go through this. When the air is holding as much water vapor as it can, does anybody know what that's called when like a sponge is 100% filled up? SpongeBob, yep, that's it, SpongeBob.
SpongeBob.
No, it's not. It's called saturated.
What?
You guys know that word, saturated?
Remember SpongeBob?
No. Okay, that's slightly different. What that means is it's all single bonds instead of double bonds, which means it can't bond with anything else because all the bonds are taken up. That you'll learn in chemistry next year, so that was not earth science. But it still makes sense. Huh? Oh, did you talk about that last year then? Saturated versus unsaturated? Yeah, I didn't think so. But do you know what I would mean if I said the sponge is saturated? All filled up with water, okay? So then what's the relative humidity when the air is saturated? 100%. And now I want to talk about temperature and relative humidity. Guys, what happens to air molecules when we, let's say, heat them up? Well, they don't explode. They do shake. When we learn temperature density, what happens?
They're bigger.
They themselves don't get bigger, they spread out. So they expand, not the molecules themselves don't expand, but they expand like where they are so that they aren't near anyone. If you recall, I always compared this to on a hot, sweaty day, what do you do with the people around you? You don't touch them. Exactly. Because you don't want to touch other people's sweat. I agree. Yeah, you wrestlers are a different group of people. What I was talking about is hot, sweaty people typically don't like to touch each other. So they spread apart. Right now, looking at this room, would you say this room is densely packed or loosely packed right now? Work with me, people. There's like 10 of you in the room.
They're all like.
Okay, not a lie. Up here is more tightly packed than back there. But could we be more tightly packed in here? Definitely. So right now we're fairly loose. You guys gotta stop and let me teach. While you're funny and hilarious and I enjoy the entertainment, it's really disrupting learning. I know, that's what I'm telling you right now. So here's what I was saying. You're loosely packed. Do you see all the spaces in between you? If you guys were air molecules, do you see all the room for water in between you?
Yeah.
Okay, so air molecules, lots of room for water right here. Now, do you guys want to tightly pack or can we just use our imagination?
We have to.
Jeff says we should. What about the rest of you?
I think we should.
Jeff and Carter say we should. Can we outnumber them, guys? Okay, Good, we got a couple no's.
That's one,
Raise your hand if you say no. They win.
that's four.
Me and the Cindy are also raising our hands.
1, 2.
So
That's-
imagine
Come on, let's
tightly packing yourself. How would it look different? Jeff, if we did tightly pack ourselves, how would it look different in this room right now?
take a bulldozer and then like flood the room.
Okay, Felicia.
Like a small section.
Okay, so we'd all be in one small section. Would there be room for water in between if you were air
I
molecules?
don't think so.
No. So when it's cold, the air cannot hold as much water because the molecules are too tightly packed for there to be room for water. So when it gets cold, there's no room for water. And I always say, the saying I guess I have for this is temperature and relative humidity, warm air can hold more water than cold air. You must get comfortable with that. Warm air can hold more water than cold air. There's more room for water when the molecules are warm and spread out than when they're tight and packed in. We're gonna skip this drawing for right now. We already talked about these instruments, right? All right, so we already labeled this one hygrometer and this one is sling psychrometer. Now we have to talk about dew point. You guys heard of dew before?
Yeah.
What is dew and where is it? Stuff in the morning on the grass. What is that stuff?
Water.
It's water. Does it have to rain to get dew on the ground?
No.
No. It has to do with air temperature. When else is there dew? Not just the morning, there's some other times when there's dew.
Night.
Yeah, typically like when it first starts getting dark out. What happens? So Ryder already talked about this. What happens at night that might cause that dew to form? When the sun goes down, what happens?
Temperature.
in the air is cooler than like the temperature on the ground, so it's pretty water.
You got it. So temperature in the air, or the temperature of the air cools down. And what did we just write 5 seconds ago? Warm air can hold more water than cold air. So if the temperature cools down, the air can't hold as much water. So it drops it off in the form of dew on the grass. Can you think of any other times in real life, this doesn't have to be earth science-y, in real life where water droplets are forming because of a temperature change? On the outside of a cold glass. You've got a cold glass of water, or a cold glass of pop, or a can of pop. You know the moisture on the outside? Is the glass leaking? We typically call this sweating, I think. Like my glass of pop is sweating. Is the glass leaking? No. What happens then? How does that get there? It's called condensation, but that's not what I asked. How did it get there?
All the water molecules are in there and then
In where?
in the air.
Okay, in the air. Good answer.
They get dropped off on the glass because it's a lot colder than the temperature.
Okay, the cold glass. Now, my family's not doing it because it's insulated, but if we've got cold water in a glass usually, and the warm air touches it, again, that cold, once it gets cold, it can't hold that water any longer, so it leaves behind the sweat or the condensation on the bottom. Can you think of any other times? What? No, sweating's different. Sweating is coming out of your body. Can you guys think of any other times when condensation might form on things? When do your windows get foggy? Okay, one time. You've definitely done. How about cold outside and warm inside? Oh, it's not, really? All right, there we go, a little bit. Why did the condensation just form on the window?
Because
My breath is hot, the window's cold-ish, And so my hot air filled with moisture hit the window and got
What if you're
cold.
in a car after like a football or?
Yes.
a sports game?
You hot, sweaty people get into a cold bus, the windows are cold, and your body heat, hot, sweaty air touches the cold window. And again, the hot air can hold all that moisture, and then it hits the window, and now it's cold, and it drops off all the moisture, because the cold air can't hold it. There, I think you guys got some really good examples. So let's fill in the definition of dew point. I have this on PowerPoint, so you don't have to read through my writing. Right there. So the temperature at which water comes out of the air. It's also, if the water's coming out of the air, what's the relative humidity then?
Human.
Very humid. In fact, if it's coming out, it must be 100. So to figure out relative humidity, we're gonna actually use the same instruments you use to find relative humidity, and dew point use the same instrument. So they both use that hygrometer and the psychrometer that are there. And we're going to talk about how we use them now. I just wait until everybody has this one in their notes. So I think I broke out one of these guys to show you yesterday.
Go to them.
I'm going to. This is a sling psychrometer. It's the cheaper of the two instruments that are used to find relative humidity, hence the reason why we have them. They're the cheaper ones. And they're kind of more fun to use too, because like I said yesterday, they were the original fidget spinners. Okay,
But they're not like, they don't have like three things.
I know, they're not as cool, but dude, come on. Isn't it neat? Like-
So we could do that?
No, you drive me crazy. Again, I think we started this yesterday. We have two thermometers. One's wearing a sock. We talked about this. Okay, one's wearing a sock. Did I tell you that we then make it a wet sock?
Yeah,
Okay, did I tell you why we make it a wet sock?
yeah,
Why?
because when it gets wet, then, when it gets cold, then it makes it.
You got a lot of the important parts out of there. Guys, when the water evaporates, we talk about sweating. Okay, so why does your body sweat?
To make you warm.
Because you're hot.
What?
And when you get hot, your body sweats, and you've always been told that you sweat to cool off. It's your body's way of helping you cool down. But what no one ever told you in your gym classes, in your health classes, or your elementary school science classes, nobody said, well, how does that make you cool off? Nobody ever mentioned that. And what we talked about yesterday is that when water evaporates, it takes energy away. So it makes things colder when there's evaporation. So evaporation causes energy to leave. So same here. When you spin this around and it loses its water through evaporation, that wet bulb, or the one with the wet sock, is going to get colder. The one without it, it's gonna just measure, what is the one without the sock measuring?
The temperature.
Yes, just the normal average temperature in the room. You have two different temperatures. In fact, you have the regular air temperature and the temperature after evaporation. That's gonna go on the top of the next page. I added a third definition here. And that's called the wet bulb depression. I'd like you to add that one underneath wet bulb on page 34. So we did yesterday, we did dry bulb yesterday, the actual air temperature. We did wet bulb, the temperature of air cooled by evaporation. Can you add that next bullet, please? Wet bulb depression. Do you guys know what the letters AKA stand for? Okay, just checking. Also known as, this is also just called the difference between the wet and the dry.
Where do I put that?
Right? Make your own bullet. Hopefully you have room in that little space.
Nope.
You want me to come write it for you, Carter?
No, I got it.
Okay, I'll do it if it's too much.
Wait, where if you put the sock in warm water?
If you put the what? If you put the sock in warm water? So immediately the temperature would raise, but when you spin it, it would still evaporate, it would still get colder.
If you make it really.
If you make it really cold?
Yeah.
Same thing, initially it will drop, but when you spin it, it won't be that cold. Because it'll then just get the temperature after evaporation. So that's why we don't just spin this for 2 seconds, you spin it for 2 to 3 minutes.
Well, there's a lot of time there.
It is a lot of time, it's not an easy process, or quick process. Not that difficult, though. All right, so now we gotta talk about, well, what do you do with these numbers? And what you gotta do is get a table out. Some of you already have it open, it's page 12 of your reference table. So keep your packet open to that page because there's some examples there. And then we're just going to practice with our reference table, which is page 12. This one, I don't think we need bigger versions of this one, but if anyone is having trouble seeing it, please let me know. What does page 12 look like to you? Does that remind you of anything you've ever done in your life before?
No, it's like something I did before. It's
Oh,
called
just
graph
graph.
or something.
It looks like what?
It's like a graph.
Okay, I don't see, how about, does it look like this to anyone?
Nope.
It doesn't? Well, let me tell you, it works like this. Do you guys ever use a multiplication table like this?
No.
My daughter, especially Mallory, the younger one, like totally relied on learning her multiplication facts through this.
When I was like,
Yeah, I'm talking about when you were much younger. Do you remember how they work? Let's say I want to do, let's do 9. Those are hard. Let's do 9 times 7. How do you use this table? No, Jeff, not that one, this one. How do you do 9 times 7?
Go to 9 and
Go to
then
9. Oh, wait, do I go to this 9 or this 9?
Oh.
Oh, it doesn't matter, okay. 9 and then what? 7.
Then you go to where it meets.
Then, okay, so you guys do remember, 63. Now, did it matter? You already told me it didn't matter. What if I did 7 on this side and 9 times this one? 63. You guys remember doing that?
Yeah.
This table, page 12 of your reference table, works just like that with some slight differences. I just want to get a brand new one out so I can show you how I want to label that. So with this one, unlike what you guys just talked about, this one, it does matter. This one, you have to, going down the side, it has to be the dry bulb on the side. Okay, so that's not negotiable like the other one where you could have switched it. Here, it has to be the dry bulb. As we just wrote, what is the dry bulb? What does that actually measure? And I want to label that. So physically grab your reference table and add that label, actual air temperature. I'm going to do it on both these charts. I don't know if you noticed, there are 2 almost identical charts. The top one is specifically only for dew point. The bottom one is only for relative humidity, but they work exactly the same. Oh, I should have said actual air temp. I forgot that part. So the side is the actual air temperature. What's the top for both charts? Read your reference table. What's the top for both? Difference. Guys, circle that word difference. It's the difference between the wet bulb and the dry bulb. It's not the wet bulb. It's the difference. How do we find difference? Subtract. Notice these are always positive numbers here. See how the top line is all positive? To get a positive, do we do dry minus wet or wet minus dry? Dry minus wet. How did you know?
Because those numbers are bigger,
Which ones are bigger?
right?
Dry is always going to be bigger because remember, okay, actually it's either going to be bigger or the same. Because the wet bulb is either going to stay the same or get colder. It will never warm up. So it's always dry minus wet. Other than that, it works literally exactly the same as the multiplication table. So let's try this one out. We have example 1 here. If the dry bulb temperature is 20, I'm going to fill that in. Dry bulb temperature, 20 degrees Celsius. And the wet bulb is 15 degrees Celsius. Find the dew point and the relative humidity. So what's the first thing I should do? Let's find the difference. Now, I'm going to tell you guys, if you even question whether you're subtracting correct, get a calculator and use a calculator. Because boy, would that suck if you did this math and the answer is 5 degrees Celsius and you thought it was 6. Now, obviously, I don't think anybody's messing this one up, but there is math that people mess up. And I would hate for you to get the question wrong because you subtracted 14 minus 8 incorrectly. That's not this problem. That's just a number I made up. Now, what do we do with this? Now that we know the dry bulb was 20, the wet bulb was 15, the difference is 5. How do we find the dew point? First of all, which chart should we use? The top one or the bottom? Okay, top, because that one's labeled dew point. Now, just like the multiplication table, you take the dry bulb, point to 20. That was right out of the problem, so I'm not making this up. It's right out of the problem. And then what number do we point to along the top? 5. You point to the difference. So everybody grab your reference tables and literally do this with me. Bring your fingers together. And you end up at 12. Did everybody end up at 12? Jeff, you gotta be on the dew point one, or did you already do that?
Yeah,
You already did and got 12?
yeah.
Do you write it down?
Oh,
So right here, the dew point is 12 degrees Celsius. Let's do the relative humidity. What's the relative humidity? How do we do that? Same way, just using the other chart. 20, dry bulb, 5, difference. Bring your fingers together and write down your answer on the relative humidity blank. Perfect. Perfect. Yep. This is super easy to screw up. So some people like to try and use their eyeballs to match them up without truly using your fingers like a little kid on the multiplication table. But if you try to use your eyeballs, odds are you're going to end up drifting. So I definitely recommend actually using your fingers. I have also seen plenty of people actually drawing lines and then circling answers. Totally fine with that. If you're using pen and you mess up your reference table, I'll hook you up with a new one. Do whatever it takes to make sure you get the right answer. The other thing I do want to point out, a lot of people assume that first column is 1. It's not, it's 0. So if you're going like from a dry bulb and you're just trying to get to 1, some people mess up their counting. So actually look at the columns that you're using. You think you get it? So let's take a look at your homework. I didn't write it down, but you still have homework. You ready? You ready? Here, I'm telling you your homework. Carter, Zach, you paying attention? Flip over your page to page 35. Get your pens ready. You're going to do every other, so 16. The one that starts with 4. The one that starts with 26. The one that starts with 28. Then the first blank one, the third blank one, 17 and 5.
Wow.
But I want to do one of these together because some of them are tricky. So notice again, if you're confused which ones we did, it's every other starting from the top. I want to do this 28 one. So this is one of your homeworks that I want to do with you. This one's weird. So I give you a dry bulb temperature. I do not give you a wet bulb temperature. I did not give you a difference. I did not give you a dew point, but I gave you a relative humidity. What the heck are we gonna do with this information?
You can find the difference.
So we can work with what they give you. That's what I call it. I talked about it when we did some other reference tables, but work with what they give you. They give me a dry bulb temperature and they give me a relative humidity. So because they gave me a relative humidity, I'm gonna come down to this relative humidity chart. They gave me a dry bulb of 28. So I know that. And they gave me a relative humidity, what was it? Of 31. Watch this. I'm finding the 28. I'm using the 28 dry bulb, and look at that. There's a relative humidity of 31 there. Now that I know the relative humidity is 31, dry bulb 28, off this chart, what else do I know now? I now know the difference is 11. So I work with what they gave me, and I knew the dry bulb, I knew the humidity. Now I know the difference is 11. If the difference is 11, can I figure out the wet bulb? So how this works is 28 minus what gives me 11?
28 plus 11.
Now, we can't do plus 11. So because that would be 39. You're right, the difference between that'd be 39. You're right, the difference between 39 and 28 is 11, but there's something drastically wrong with that. Can we have a wet bulb of 39? Because the wet bulb always has to be colder. So this is a little bit, I guess, of algebra, if you want to call that. 28 minus something equals 11. How do you rearrange this? Everybody hates this.
Yeah, you got it.
Okay, so in the end, 28 minus 11 is 17. So now we know the wet bulb is 17. The difference is 11, and you can take that information and find the dew point now. So again, page 35, every other in the chart is homework.
Oh. So you say every other one?
Every other, starting at the top and working down.